Hi everyone, today's topic is solving systems of equations using the substitution method. As a reminder, you do not need to write down everything we cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind the video to view information again, and fast forward if you think you got it. Just be careful and make sure you don't fast forward so much that you miss out on something important. Let's begin. As a review, a system of equations is a system where you have two or more equations working together. Instead of solving for one variable, you're solving for two variables. And those two variables need to work for all the equations in your system. There are three methods to solve a system of equations. The first was graphing that we already went over. Then we have substitution, which we'll cover today. And lastly, one of my favorites, elimination. So today we're covering the substitution method. And as a review, to substitute means that you have someone or something acting in the place of another. So in the school setting, we know substitute teachers. They are acting in the place of your teacher who's not there. They're doing the same function. In a basketball game, you have a substitute. So if your forward is taken out of the game, then you are substituting another player that can also has similar skills to the forward. So it's someone or something acting in the place of another. So using that concept, we are going to talk about the substitution method and how that can be used to solve a system of equations. Okay, now we're going to go over the steps to using the substitution method. There are 4 basic steps. Don't worry if they don't make sense to you right now. We're going to go over some examples. The first step is to substitute or replace a variable into the other equation. Then your equation should now only have one variable. You're going to solve that equation normally. Then once you have that value, you're going to substitute the variable with that new value and solve for the remaining variable. So you're actually substituting twice in the substitution method. Then at the end, after you substitute twice, you should have the value for both variables. And then of course your last step is to test the ordered pair to make sure that it indeed makes a true statement for each equation before you submit the answer. So make sure that this is in your notebook, the steps, because it can be quite confusing. And we are going to go on and work with some examples. Okay, here is an example on Khan Academy. It says to solve the system of equations, and you're going to be using the substitution method since that is the topic here. Go ahead and pause the video, see if you can figure this one out on your own first. All right, this problem is already set up for an easy substitution. It's basically saying you have two equations. One is negative 4x plus 11y equals 15, and the other is x equals 2y, x equals 2y. This right here is already set up for easy substitution. It's saying instead of x, you could put in 2y. So if x was taken out of the game, 2y would be substituted in instead. This one is the other equation. So what are we doing? Instead of negative 4 times x plus 11y equals 15, we're basically going to sub out this x, okay? And instead of negative 4 times x, we're going to put negative 4 times 2y. So if you saw what we did there, we took out that x and we put in 2y instead. We're saying x, you're coming out. Instead, we're subbing in 2y. Now be careful, this negative 4 is being multiplied by x, so it needs to be multiplied by 2y as well. By putting in parentheses, it shows that it's multiplication. Some people like to just put a dot there to also show multiplication. Just be careful that you don't put in an x because x could mean the variable or multiplication. Okay? So that's all that substitution is. Instead of the x, you're putting in the 2y because it told us x is literally equal to 2 times y. They're the same thing. So wherever you see x, you could put in 2y. You will notice now that this equation originally had x and y, and now it just has y's. That's a good thing. We want that. Because once it just has y's, we can solve for y. We got rid of that x by replacing it with a value that also has y. So let's solve it so you can see what we're talking about. 4 times 2y is 8y. Oh, and that's negative. And then we're going to add it to 11y and equal to 15. Now negative 8y plus 11y, they are like terms, so we can combine those. Negative 8 plus 11 is 3y. You can use the calculator here. So they are like terms. Negative 8 plus 11 is 3. Keep that y, and you have a 15 on this side. If I want to get y by itself, I need to, instead of 3 times y, do the inverse operation, which is divide by 3, both sides. 3 divided by 3 is 1y. 15 divided by 3 is 5. Boom. We got ourselves one of the values. Y equals 5. Okay? So substitution requires just kind of like figuring things out piece by piece. Once you figure out that y equals 5, think to yourself, what can we do with that value? And I'm looking at this equation right here. What can I do with y equals 5? If you said that you can put y back into the equation, you are correct. Let me go ahead and clean that one up so you can see what it originally was. It originally was x equals 2y. Now that we know y equals 5, we're going to do substitution again. X now equals 2 times 5 because y is the same as 5. So then that means x equals 2 times 5, which is 10. So we have x equals 10 and y equals 5. That's our answer. Now, before I submit, I owe it to myself to just double check it out, right? So let me check it out here. Negative 4 times x, my x is 10, plus, let's see, we have 11 times y. My y was 5, should equal to 15. So negative 4 times 10 is negative 40. 5 times 11 is 55. 55 minus 40 is 15. So that works. And then we have x equals 2y. So x is 10, y is 5. Does 10 equal 2 times 5? Yes. So I'm pretty confident that 10, 5 will work here because it gave us true statements in both of the equations. And it does. Okay? So substitution is just basically substituting that value for the other one, solving it. And remember, when we got rid of that x, we were able to just chill and solve for y because it was our only variable left. That's a good thing. If you did not understand that problem, make sure that you rewind, jot down your notes, look it over again before you move on to our next example. Okay, here is our next example. It says solve the system of equations, and you have 2 equations here. Go ahead and pause the video and try it on your own. All right, so first I'm going to look and see if there's anything that can help us easily substitute. And you should have found that y is by itself, and wherever you see y, instead you can put in negative x plus 2. So I see a y here. Later on I can plug that in instead. Let's rewrite that. Instead of 5x minus 7 times y, I'm going to put 7 times negative x plus 2. I'm going to put it all in parentheses because those go together. So again, instead of 7 times y, I put in 7 times negative x plus 2 because that's what y is equal to. So y got taken out, and instead of y, we put in negative x plus 2. And then we can solve it, and we just have x's left over. So at the end, we should get an answer of x equals something. Let's solve this. This is 5x. This is negative 7 being multiplied by everybody inside. So we got to be careful there. Negative 7 times another negative is positive 7. Keep that x. Negative 7 times 2 is negative 14. So it becomes a minus 14. And then we got rid of our parentheses. Then we're going to combine our like terms on this side. 5x plus 7x is 12x. Minus 14 equals 58. Let's get our x's alone on this left side by getting rid of this 14. Inverse operation, we got to add. That cancels, so I get 12x equals, this is 72, I believe, yes. And then the last step is to get rid of this 12. It's being connected by multiplication, so we want to divide. So 12 divided by 12 is 1x. 72 divided by 12 is 6. So x equals 6. Halfway there. Now that we have x equal to 6, we can go ahead and take that information and plug it in back into the problem. So instead of y equals negative x plus 2, we're going to put y equals negative, x was equal to 6, negative 6 plus 2. So now y equals to negative 4. So we have the value for x and y. Gotta double check it because I don't want to go through all that work and have it be wrong. So let me check it. Instead of 5x minus 7y equals 58, I'm going to put in 5 times 6 minus 7 times negative 4 should equal the 58 and get a true statement. This is 30 plus 28. Does that equal the 58? Yes, it does. 30 plus 28 is equal to 58. Try that the second one. Y equals negative x plus 2. Instead of y, we're putting in negative 4. Instead of negative x, we're putting in negative 6 plus 2. And that is correct as well. So I'm pretty confident that that answer is correct. And it is. Okay, here's another example of a substitution problem. This one might look a little bit different. Go ahead and pause the video and try it on your own first. Okay, for this one, you should have seen that x is equal to negative 8. That right there is setting up a substitution for you. Wherever you see x, you can substitute it with negative 8. So in the other equation, instead of negative 9 times x, you're going to put negative 9 times negative 8. Minus 9y equals negative 9. So it doesn't have a variable in its substitution, it's just a number. So instead of negative 9 times x, you're putting in negative 9 times negative 8. You're going to still solve for y. Negative 9 times negative 8 is positive 72. Minus 9y equals negative 9. You're going to want all your numbers on the right-hand side. This is positive 72, so you're going to subtract 72. So you end up with negative 9y equals, this is negative 81. And let me get rid of this real quick because I ran out of room. And instead of negative 9 times y, you're going to want to do the opposite, which is divide by negative 9. Don't forget the negative to both sides. And you're going to get y equals, this is positive 9. So y equals positive 9. And then you have x already. X is equal to negative 8. So you have negative 8, positive 9. And you kind of already checked it by putting in those numbers in there, but you can definitely do that as well. Negative 9 times your x minus 9 times your y should equal to negative 9. So this is 72 minus 81. That should equal negative 9. And it does when you check in your calculator. So this is negative 8 and 9. Let's try and see if it is correct. Oops. -8 and -9. Oh, +9. Whoops, I put in the wrong thing. -8 and +9. All right. Okay, here is one last example. And in this example, it says to solve using substitution, you have the two equations y equals 4x plus 2 and y equals 6x plus 6. Go ahead and pause the video and try it on your own. All right, in this case, you have two equations and they both start off with y equals. A lot of times people get confused here, but this is actually an easy substitution problem once you know what you're looking for. So if both of them equal to y, then basically you can look at one of them as y equals this stuff, and you can replace it in the other one. So the other equation says y equals 6x plus 6. Well, the first equation says y equals 4x plus 2. So instead of this y in that second equation, you can replace it with 4x plus 2. So you end up with 4x plus 2 equals 6x plus 6. So you're basically having the second parts to both of the equations, 4x plus 2, equal to each other, equals to 6x plus 6, because the first parts are already equal to each other. So it's basically like you saying y equals y. This y is equal to this y. 4x plus 2 is equal to 6x plus 6. And then it looks kind of funky, but you can solve it still. I'm going to move my smallest variable over. So 4x needs to subtract 4x to get rid of it. So you end up with 2 equals 6x minus 4x is 2x. Keep that plus 6 on the other side. Now my x's are on the right-hand side. I need to move my numbers to the left-hand side. Subtract 6. That cancels. So I end up with 2x equals 2 minus 6 is -4. This is going to be divided by 2 to get rid of that. So -4 divided by 2 is -2. So I end up with x equals -2. And then if I wanted to figure out y, I can just put -2 back into where x is and solve that. So y equals, instead of 4 times x is 4 times -2, so that's -8 plus 2. So y equals -6. Okay, I can double check that in the other equation. Instead of y equals 6x plus 6, I have y equals 6 times, my x was -2, plus 6. So y would equal the 6 times -2 is -12 plus 6. So y equals -6. Does y equal -6? Yes, it does. Okay. So it looks like our answer is -2, -6. -2, -6. I'm going to type it in correctly this time. All right. So when you have two y equations, y equals blah, 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 and y equals blah, 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 you just have those two blah, blah, blahs equal each other. So substitution, there's basically 3 different types of problems they could ask you. Make sure that you are showing all your work, checking your work, because there's a lot of steps. And let me know if you have any questions as you work on these. I'll see you in class.